All right, so next problem here. So this is a very typical picture, right? So there's only one figure, right? It's a triangle, but I hope you see the two triangles in this one figure, right? There's the big triangle QRS and the small triangle I'll do in green QXY. Now notice, again, your ways of proving triangles similar are angle, angle, side, or side, side. They give you no numbers. How are you supposed to even do this problem? Well, look here. We have parallel lines. So if I look at XY and RS as a pair of parallel lines, right? What's my transversal? So let's just use the left side. QR goes through there. So this is going to provide what are called corresponding angles. And if lines are parallel, corresponding angles are congruent. So it's not alternate interior, right? I see an angle made here and this angle made here. Those two angles will be congruent. So with three letters, let's go angle QXY will be congruent to angle. So QXY, QRS. Now we could also do the other side as well, but let's just be different and let's use this top angle. Is an angle Q congruent to itself because it's used in both triangles? And now look, there's your angle similarity. These two triangles are similar by angle similarity. So let's write it out. So first, we said that angle QXY is congruent to angle QRS, and that's because they're corresponding angles. And then we know that angle Q is congruent to angle Q, and that's by the reflexive property. And now we know that the two triangles are congruent, and I can name them the same way I named the angles. So triangle QXY is similar to, sorry if I said congruent, I didn't mean to. They're similar, is similar to triangle QRS, QXY, QRS, and that is by angle similarity. So again, don't be confused by the picture of a triangle inside a triangle or the fact that there are no angles or no side lengths given. All right, next one, same deal here, right? So now I have a triangle inside a triangle. So again, hopefully you see the big triangle is here, KMN. The small triangle is here, KLP. We need to try to see if those two triangles are similar. Your ways are angle, side, side. So this time you're not given parallel lines, but you're given some numbers, right? Don't you have some side lengths? Well, first, I see that these sides, LP and MN, aren't given. So it's not all three sides, so it has to be side, angle, side. So where's the angle? Well, just like in the last problem, angle Q was shared by both. In this problem, angle K is shared by both. So angle K is congruent to angle K. And now we're going to work on the sides. So the side of the small triangle up here to the left is 8. What's the length of the side of the big triangle? Is it 2? Well, would that make sense? If I'm telling you that the big triangle is bigger, why would I put a smaller number here? To get the length of the big side, I have to do 8 plus 2. That's 10. That divides and you get 0.8. Okay, now let's do this side. So the short side is 12 over the entire side, which is 12 plus 3, that's 15. So what's 12 divided by 15? That's also 0.8. And there we go. These two triangles are similar by side, angle, side. If one of the sides did not have the same ratio, you would just say not similar. So in all of these examples so far, they've always been similar. So I tried to do it on purpose so you could see how you'd answer them. If something goes awry, you just say not similar and you're done. If you want to explain why it's not similar, that's a bonus, but not similar is fine. So I hope you see, you're not going to see a lot of not similars potentially, right? Just maybe one to trick you up. Okay, so let's do this. So first of all, angle K is congruent to angle K. And that is by the reflexive property. It's shared. And then our side lengths. So let's say KL divided by KM is equal to KP divided by KN. And they both came out to be 0.8. So therefore, these two triangles are similar by side angle side. Triangle KLP is similar to triangle KMN by side angle side similarity. Okay, got one more video with, I believe, a couple of those extra indirect measurement problems.